Good afternoon, guys. What is going on today? I will be going over TCP dump, the basics room on TryHackMe. It is not one of the junior penetration testing path, but it would not hurt to know about the TCP dump because that would be part of like the Wireshark, just intercepting traffic and just knowing about traffic protocols and stuff. So knowing about this will definitely help you in your career, and just knowing or going over the junior penetration testing path. So without further ado, let's go ahead and get the machine started. I know it would take at least a couple of seconds to start the machine. It will give you, it will just split it halfway, and then it will just start the machine here. We probably will be going over that in our Cali machine here. So I don't think I would need this, but once it starts up, I'll go ahead and minimize it and then just SSH to the IP address that they will give me. It would take maybe a couple of seconds, yeah, 30 more seconds to start to get your. Actually, I could still exit split view. And obviously, I probably would not read every single thing word to word because it's gonna take a while for me to read it. But whenever you are stuck on a question, or if you would like to take your own time and read it, then you can just always pause the video and go over it. Go over the notes and then answer the questions. I will be solely focused on the questions only, just to save some time, because I know this room might be a little too much reading going on and it's going to take a little while. So for the introduction, we are working on TCP dump. So the main challenge when studying networking protocols that we don't get a chance to see the protocol conversations. All the technical complexities are hidden behind friendly and elegant user interfaces. Your access resources on your local network without ever seeing an ARP query. So you would access internet service for years without seeing a single handshake till you check a networking book or inspect the network traffic capture. That's pretty much what we're trying to do right now. The best steady aid would be capturing traffic and taking a closer look at the various protocols. It helps us better understand how networks work. This room introduces some basic command line arguments for using TCP dump. TCP dump tool, it is lib pcap library are written in C and C++, and it was ported to the Windows, Microsoft Windows, Win pcap learning objective. This room is aimed to provide you with basic necessary to use the TCP dump. Okay. Prerequisites: it is good to know networking concepts, networking essentials, networking core protocols, and networking secure protocols. Obviously, I've went through this rooms, but I will go ahead and probably make some videos on these as well. But without further ado, what is the name of the library that is associated with the TCP dump? It was already given to us right here. This is the library, the lib pcap. Our library pcap. We go ahead and SSH to our room. This is our IP address. Let's go ahead and copy it, and they already give us the username and the password. So let's go ahead and SSH. Probably the password. And then yes, the password is TryHackMe123. Yes, and then if we do who am I, you are logged in as the user, and if you do clear and ls, you have the traffic pcap file that is already captured. Okay, you can run TCP dump without providing any arguments. However, it is only useful to test that you have it installed in real scenarios. Installed in a real scenario, you must be specific about what to listen to, where to write, and how to display the packets. English is so bad today. First thing to decide is which network interface to listen to. To do that, you just put TAC I and the name of the interface. In our case, you can use the command shown as IP address show or IPAS, written like this, IPAS, to see which interfaces you have available in that machine. So we could do IPAS to see we have our the loopback, which is the LO, and then the only interface we have is the ENS5, and that would be okay. Save the captured package. To save the captured packet, you just put tag W in the file name, and it will automatically save it as that pcap file. To read a file from, for instance, if we are trying to read a file from the traffic pcap, we will be using TCPDUMP R to read from the file, and we'll just read the whole thing, but we don't want that right now. Control C it. And then you can specify the number of packets to capture by specifying the count using tag C count. So to use tag C and then 5 or 10 will just only catches or the number of packets that we are specifying right here. We'll continue to until you interrupt it. For example, by pressing Control C, depending on your goal, you need a limited number of packets. Okay. Don't resolve IP addresses and port numbers. To not resolve IP addresses and port numbers, you just use tag N argument. And if you put tag NN, it will stop both DNS and port number lookups, which is good in our case. And then, for instance, if you're just trying to do sudo TCPDUMP tag I, we'll be using the interface, and then the interface that we will be using is this one, and we wanted to catch only 5 counts of just packets, and then we tag N will just stop the as you can see right here, tag N will stop the DNS port, the DNS and port number lookups if you do tag NN. So let's go ahead and run that real quick. Sudo TCPDUMP. I don't think we need sudo, to be honest, but tag I, we will be using, what is our ENS5? Yeah, ENS5. You just, and then tag C. Would it be uppercase or lowercase? Oh, lowercase. Yep. C5. Tag N. And it would TryHackMe 1 2 3, and it would just capture 5 packets. If we had done 10 right here, it would have. You see how it took 10 packets, and that's pretty much what the idea is. Produce more verbose output. To produce more verbose output, you just put tag V. To make a more verbose, you would just use tag BV twice. And right here, the summary and the example, we have TCPDUMP tag I interface that will capture packets on specific network interface, which is in our specific interface here. Tag W file would write captured packets to a file. TCPDUMP tag R reads from captured packets from a file. TCP tag C will get a specific number of packets. Tag N will do not resolve IP addresses, and tag NN do not resolve IP addresses and don't resolve protocol numbers. And tag V will verbose display or verbosity can be increased by tag VB or tag BVV 3 times. Okay, consider the following examples. So let's say we have TCPDUMP tag I, ETH0, tag C50, tag V. This captures and displays 50 packets by listening on the ETH0 interface, and which is a wired internet, and displays them verbosely. Sorry. And then TCPDUMP tag I, WLO1, tag W data pcap. This captures packet by listening on WLON interface, which is the Wi-Fi interface, and writes the packets to data pcap, which is tag W. We'll just save it. And tag I any captures packets on all interfaces and displays them on the screen without domain name and or protocol resolution, which is really nice to kind of memorize it and just know it off the top of your head. What option can you add to your command to display addresses only in numeric format that you are putting tag n, because you are avoiding for it to be resolved. Okay. Although you can run TCPDUMP without providing any filtering expression, though that won't be useful. Just like a social gathering, you don't try to listen to everyone at the same time, which is true. You can filter it. You can filter it by host. To do that, you just put sudo TCPDUMP and then host, and then you put your host name, and then you can save it by tag W. You can filter it by port number. You could just put TCPDUMP tag INS. And then tag I would just specify the interface name, and then you just put the port number that you would like to get, port 53. You can always use the source host IP or source host name as a sort, to get a particular source IP address. If you want to get a destination port, you just put destination host IP or DST host name. Filtering by protocol, you can these are some of the protocols that we could use. We could do IP, IP6, UDP, TCP, ICMP, ping, or traceroute. And the logical operator, we have AND or not. AND capture packets where both conditions are true. For example, if we do this, host 1111 and TCP captures TCP traffic with host 11111. But for this to be executed, these both statements has to be true. And then OR captures packets when either one of the condition is true. For instance, TCP, UDP, or ICMP captures UDP or ICMP traffic. And then NOT captures packets when the condition is not true, which is good. Just for the summary and the example, just try to kind of go over this and memorize it. We have TCP source host IP. This will get us a specific source IP. TCP dump those DST host IP. It will filter packets by specific destination host. Port number, filter packets by port number. Source port, specify source port number, and you get the idea. And for protocol, we can use IP, IP6, ICMP, any of that. Consider the following example. We have TCP dump tag I any TCP port 22. This listens on all interfaces, and because it has tag I any, and then it would use TCP packet for our filtering protocol, and then it would just use port 22, anything to or from port 22, which is the SSH traffic. TCP dump tag IWLO1 UDP port 123. This will be listens to Wi-Fi network card and filters. This is usually a Wi-Fi network card. Filters UDP protocol on port 123. For port 123 is network time protocol NTP. The same thing goes to this one, TCP tag I ETHO, that listens to on wired Ethernet interface and filter traffic exchange with example.com and uses TCP and port 443. Same thing as goes for this one. We reading it from traffic pcap. We counting only five of them, and we putting tag n, which is good. Right. So we could always use the word count to give us, like, how many output we have, so we don't have to manually count line by line. So we can always use WC, or we could just do word count tag L to count the line. So how many packets and traffic pcap uses ICMP protocol? For that, we would just use TCP dump tag R to read from the traffic, and our protocol is ICMP, so ICMP, and we are not about to count one on line by line, so we just go ahead and pipe it to word count, and we just use tag L for our line, sorry. So we have exactly 26 line. So that should be the answer for the first question. Okay, what is the IP address of the host that asks for MAC address of 192, 168, 124, and 137? This right here would be the ARP resolution. That is, the protocol that matches the IP address with the MAC addresses of the, on the client or the host. To do that, we are I would go ahead and TCPDUMP tag R, because we're reading from the traffic pcap, and we'll do our protocol, and we'll do tag N because we don't want it to use the resolution. And what is the question? What is the IP address of the host that asks for MAC address of 192? We looking for the IP address. It should be this right here. Did I copy it? I hope so. Let's go ahead and paste that over here. Okay, what host name of subdomain appears in the first DNS query? To get the DNS query, we do the same thing. We don't need the ARP, but we need either DNS or sorry, not DNS. DNS is on port 53, so let's go ahead and do port 53. But we will do tag N. Tag N, and what are they looking for? I hope you guys understand that what we are doing right now, currently we're using port 53 because that port 53 is, according to our note earlier, it is domain name service right here. Filtering by port, if you want to capture all DNS traffic, you can limit the capture packet to those on port 53. According to our note, that's why we're using port 53. And what is the host name? Subdomain appears in the first DNS query. The subdomain in the first one, since they only asking for the first one, the first subdomain that we see here is the mirrors rockylinux.org. That should be the answer. Okay, and for the advanced filtering, we are somewhere around 17 minutes, so it's fine. So there are many more ways to filter packets. After all, in a real life situation, we need to filter through thousands or even millions of packets. It is indispensable to be able to express the exact packets to display. For example, we can limit the displayed packet to those smaller or larger than a certain length, which is good. We could do greater than the length that we want. That will filter packets that have a length greater than or equal to the specified length. Less, we could use that, less length, to have a length less than or equal to the specified length. We should check out the pcap filter manual page. Well, we're not doing that right now by just using man pcap filter. Let's look at binary operations. Just it's good to know your binary operation, which is this right here, and this is OR, and then this is NOT right here. As you can see, N takes 2 bits and it returns 0 unless both inputs are 1, and then OR takes 2 bits and returns 1 unless both inputs are 0, and then NOT takes 1 bit and inverts it, and an input of 1 gives 0 and 0 gives 1. Header bytes, it is using pcap filter TDCP. TCPDUMP allows you to refer to the contents of any byte in the header using the following syntax. You just got to use the proto, and then the ARP, ether, ICMP, IP, IP6. You can use that. The EXPR indicates the byte offset size. This a little complicated. I don't think I will go over this. I'm still trying to understand every single thing about how this part works when it comes to the header bytes. But to answer some of the questions down here, all you need to know is just maybe you can use the TCP flags to refer to the TCP flags field. So for send signalize, you can use TCP send. For acknowledge, you can use TCP ACK. For finish or fin, you can use TCP tag fin. Reset and then push, respectively, as you can see over here. Based on the above, you can write TCP dump, and then you could just look for this flag here to capture TCP packets with only signalized flag set, while all other flags are unset. You could use this to capture TCP packets with at least the signalized flag set. And then this right here with at least signalized or acknowledged flag set here by using the end, and then not equal to 0. So how many packets have only the TCP reset flag set? To get the reset, you just got to use this right here, and then let's copy it, but you need to change it from send to reset, which is RST. Let's go ahead and rerun that. So we go ahead TCP dump tag R to run it from our captured file, and instead of send, we will go ahead and reset it. And we probably don't want the tag N. And what is the question? How many packets have only TCP reset? We are not about to count word to word, so we're gonna pipe it to our word counts, and it looks like it is about 57 lines, or we could just tag L it to get the line. Yeah, 57. What is the IP address of the host that sent packets larger than 15,000? What is the IP address? To get a larger or less than, we will be using this right here, greater or less. So to do that, I don't know why it takes a while sometimes for it to load. Okay, 15,000 bytes. So greater, that's what they asking for. Larger, so we are using this part right here, greater. So let's go ahead and TCP dump again, tag R traffic, and then greater 15,000, tag N. Probably a couple of them, maybe. Let's go ahead and make this joint big. It is always coming from this IP address 124.137. And what's the IP address of this? That sent packets larger than, it looks like this is the only IP address that is sending packets. There's no any other IP address but this one that is originating from. Let's go ahead. Actually, from here to this one. So it is probably this one right here, 192.148. If it's not this one, then it's gonna be this one, but I'm pretty sure it's the first one that is sending. So it's definitely not this one. So it's this one right here. I was right the first time. What's going on? Sorry guys, I'm my ear. Should be this one right here. I don't know why it's not working. What is the IP address of the host that sent packets larger than 15,000 bytes? And I did say greater. Oh my goodness, I'm so sorry, guys. And oh my goodness, let's go ahead and SSH again. I think I might have issues with the internet, maybe. I don't know why it's kind of acting up. Let's go ahead and restart again. It's just acting up. What's going on? Come on. Let's Control C. Let's go SSH. SSH. And it takes a while to load now. Look. I don't know. So probably I'm gonna just go back to my machine here. Let's go show split view. It might be might be showing small. And let's go ahead and restart again. I think I'm having some issue with the just connecting to the remote machine. Bear with me. Let me go ahead and terminate this machine. Alright, I am back again. I just had to restart the machine again. Give me another new IP address. Let's go ahead and copy it and try to see if we can SSH to that again. I don't know what's going on today, but machine has been acting up, so bear with me. Yes, it is TryHackMe. Yes, we do have the traffic pcap. Our last question. Let's go ahead and minimize this since we already SSH to it. We are on the advanced filter, and the last question they ask is, what is the IP address of the host that sent packets larger than 15,000? So to get that, we have to do TCPDUMP tag R traffic and greater 15,000. Boom. The greater than 15,000 is usually, actually let's go ahead and tag N, because we want the protocol to be written in a way that we actually want. It's gonna be this, the last dot right here you see is the port number, so you just need the first four, which is this part right here is the IP address that is sending that bytes more than 15,000. We go ahead and Control V it. Should be good. For our displaying packets, we have the TCPDUMP is a rich program with many options to customize what the packets are printed and displayed. We have selected to cover the following 5 options. So tag Q will just do quick output. It prints brief packet information. Tag E prints the link level header, and tag A will show packet data in ASCII. Tag SS show packet data in a hexadecimal format referred to as hex, and tag uppercase X show packet headers and data in hex and ASCII. To demonstrate how the above options manipulate the output, we will first display 2 capture packets without using any additional arguments. So we just use TCPDUMP tag R 2 packets. So we just go ahead and matter of fact, we can try it on our end here. Let's go LS. You see how it's traffic pcap? We just go ahead and TCPDUMP tag R traffic, and how does it run? It runs just like this. If you Control C it, if you pretty much get this, that's how it runs it. But if you were trying to use tag Q, it will just show you briefly how it looks like. Now it's a lot more visible and concise, I guess. I can go ahead and control C it because it's going to be a lot. And if we are using displaying link level header, we will just put tag E. Let's go ahead and do that. If you put tag E, it will just give you the link level header, give you more information about that, and give you the it will give you the Ethernet and the MAC address as well. Displaying packets as ASCII, you would just put tag A, which will be right here. It would just give you the ASCII. Control C it. Okay. And then displaying packets in the hexadecimal format, we just put tag XX. And then best both worlds, we just use tag X to get all the hexadecimal and the ASCII format. So for our summary, we are using TCPDUMP tag Q to quick and quiet brief packet information. We have TCPDUMP tag E that includes the MAC addresses, and then tag TCPDUMP tag A print packets as ASCII encoding. We have TCPDUMP tag XX display packets in hexadecimal format, and then tag X shows the hexadecimal and the ASCII formats. What is the MAC address of the host that sent an ARP request? We're looking for the ARP request. What is the MAC address of the host that sent an ARP request? So we go ahead and TCP dump it, tag R to read from our file, and we're looking for tag E. Since we're looking for the MAC address, we're looking for ARP request, which is our what's the term I'm looking for? For our filtering. So once you put tag I, it will give you the IP address. I mean the Ethernet, which is the MAC address, and the format is just 2222, and then they have the semicolon. Oh, the column, I guess. So that would be here. What's the question again? What is the MAC address of the host that sent an ARP request? So which would be this right here. That would be this right here. Request who has IP. This is the one. Go ahead and copy it, and we can Control V it or Command V. Boom, we are pretty much done. I didn't think it was gonna take this long. It's almost 33 minutes. But in this one, we have covered various TCP dump options along with Wireshark and T-Shark, and TCP dump is an excellent tool for better understanding